Hopefully this video will help you in using the distance formula with polygons and triangles, polygons being rectangles or squares, calculating midpoint of a line, and finding another endpoint using one endpoint and a midpoint. The first thing here is these 2 points, and you want to be able to find the distance between these two. So they're plotted on the graph here. One of the ways that you can determine this is by using Pythagorean theorem. Pythagorean theorem, which says that a squared plus b squared is equal to c squared. So you need to draw yourself a right triangle so that we can figure out what this other side is. This bottom side here is 2, and this second side here is a length of 8. And we don't know this side, so we're going to call that c. So 2 squared plus 8 squared equals c squared. When you combine these together, this ends up being 68 equals c squared. And the only thing you have left to do is to take the square root, and you come up with c is equal to the square root of 64, or it's 8.25 is the approximate decimal. Okay. Now, this is an idea that you've used probably in middle school, and so we're going to introduce to you the idea of the distance formula today. That's what we've been doing in class. So the distance formula says that you're going to take the square root of your x and your y coordinates subtracted from each other. Square them, add them together, and take the square root, and that will also give you the same distance. So, this is our x2 and our x1, and this is our x1 and that's our y1. So the first thing we want to do is just go ahead and label our points. x1, x2, y1, y2. And just plug and chug these numbers into the formula. So the square root is not going to change. These values are not going to change. So what is going to change? Well, we'll plug in the values here. So the x2 coordinate is 0. Whoops. The x2 coordinate is 0. So we're going to plug that in there. And the x1 coordinate is 2. So we're going to plug that in there. And then we're going to find the y2 coordinate, which is -5. And the y1 coordinate, which is 3. And then you're just going to simplify this. Take a moment and simplify. So you should have got -2 squared and -8 squared. And that turns into 4 plus 64. And that's the same thing that we just came up with using the Pythagorean theorem, which is the square root of 68, which is approximately 8.25. So you can see that it's two methods finding the same answer. Let's try a different type of problem. All right, this one's going to ask us to find the perimeter and the area of this triangle. So these points are plotted on this graph below. We'll call this point A, and this one B, and this one C. So 2, 3 is my A, -3, 3 is my B, and this one down here will be my C point. Find the perimeter. So you know perimeter is equal to the distance, total distance around the entire figure. And we're going to be able to use this distance formula to calculate the lengths of each of these sides. So let's start by doing side AC. Side AC. So if we were to take this distance formula, and plug in the numbers, we're going to be finding the square root of, well, what's the x2 coordinate? So that's what some of you were asking me about today. How do you know which coordinates to use? Well, you're going to use A, which is 2, 3, and you're going to use C, which is -3, -4. These are your points. x1, x2, y1, y2. And you're just going to do the same thing and substitute in where they need to go and subtract them. Take a minute, see if you can do this on your own, and then check back for the answer. How did you do? Final answer should have been the square root of 74, which is approximately 8.60. So that's the side of just AC. So here AC is 8.60. Okay? Well, this triangle is kind of easy to figure out the rest of the sides because you can see that they lie on these lines. So we just need to count the units and see how long they are. So from A to B, it's 1, 2, 3, 4, 5 units long from A to B. And from B to C, it's 1, 2, 3, 4, 5, 6, 7. 7 units long. And all you have to do to calculate the perimeter is add these up. I want to also point out to you that if we had chosen to do the Pythagorean theorem from C to A, this would have been 1, 2, 3, 4, 5 units long. And this one, obviously, since we've done the other side, will also be 7. So you could have said 7 squared plus 5 squared is equal to C squared. And you still would come up with the same answer. You would still come up with the same answer. But I just want you to know that there's 2 ways of solving these for right triangles. So perimeter, add them all up. Add them all up. You get 20.6. Now to calculate area of a triangle, which is base times height divided by 2. Our base in this case is going to be 5. So 5 times, and then the height is going to be this length here, 7 divided by 2. So that's 35 divided by 2, which is 17.5. That's our area of this triangle. Okay, let's try a different problem. Now this one we're going to calculate the midpoint. Alright, so first things first, let's plot these points. So here are these points plotted on the graph here. And you could estimate that the approximate midpoint of this line, looks to be about right there. But to be sure, there is a formula that we can use. And here's the midpoint formula that we talked about today. So what we want to do is make sure that you've labeled your points. And we're essentially taking half of the distance of the x's. That's what this divided by 2 is. Half of the distance of the x's and half of the distance of the y's. And that's going to give us the midpoint. So let's plug these numbers in here. The value of x1, I'll do that in green. x1 is 2 plus 0. That's my x2 coordinate. Let's see where I'm getting these numbers from. Divided by 2, and then I'll do the y coordinates. My y1 value is 3, and my y2 value is negative 5. Just to point out here, it would also be okay if you wrote it as 5 minus 3. These two quantities mean the same thing, divided by 2. When you simplify this, you get 2 over 2, and you get negative 2 divided by 2. And simplified even more, these points become 1 comma negative 1. So 1 negative 1 is the actual midpoint, which is pretty close to where we estimated. And if my graph was 100% accurate, it would look better. That's using the midpoint formula. Okay, so let's try one more type of problem that you're going to be given, which is when you're given one endpoint, and the midpoint, and you're asked to find the other endpoint. So in other words, you've got this point here, and it continues on past this point somewhere. Okay, it's continuing on past that point somewhere, but we don't know where it is. All we know is that this is one endpoint, I'll call that E1, and this is the midpoint, the halfway point. So somewhere down here is endpoint 2. So how do you figure out how to do that? First of all, we're going to go back to our midpoint formula. And we're going to chunk it up into 2 sections. Okay, so the first section we're going to chunk it up into is our x coordinates, and then we're going to chunk it up into another section which is dealing with our y coordinates. Always label your points. Always label your points. This is the x1 of the endpoint, and this is the y1 of the endpoint. And this is the x1 of the midpoint and the y1 of the midpoint. Okay, so we're going to start out by setting the x1 plus x2 divided by 2 equal to the coordinate of the midpoint, that is x, my midpoint x1. So that value is 0 divided by 2. So what do we know? We do know that x1 right here, the x1 value is 2. We know that x1 value is 2. So we're going to bring that on down here. The x1 value is 2. What we don't know is this x2. That's my endpoint. We don't know it. So what are we going to do? We're going to just solve this equation. 2 plus something divided by 2 is equal to 0. So you would solve this equation by getting x by itself. What is happening to x? X is being added by 2, and then it's being divided by 2. So how do you undo this? You times by 2, and you subtract 2. Okay, so let's do that. Let's times by 2, multiply both sides by 2, multiply both sides by 2. These cancel out these 2's, and you're left with 2 plus x equals 0. And subtract 2, and subtract 2, and x equals negative 2. The x coordinate of the second endpoint is negative 2. So endpoint 2, so far my x coordinate is negative 2. Alright, now let's figure out what the coordinate is for the y. If you need to take a second and pause the video and replay this section, please do so. Alright, what we're going to do now is we're going to do the same thing except with the y stuff. So my y's, y1 plus y2 divided by 2, we're going to set this equal to the midpoint y coordinate, which is negative 5. Okay, so see where I'm getting this from? Negative 5. So we're just going to plug this information in. We know that divided by 2 is not going to change. We know that equals is not going to change. And we know that negative 5 is not going to change. We also know that the only coordinate we have right now is this y1. So the y2 will remain the same. So what's my y1 coordinate? My y1 coordinate is 3. 3 plus something divided by 2 is equal to negative 5. How do we solve this? We're going to multiply both sides by 2. This leaves me with 3 plus my y2 coordinate is equal to negative 10. Subtract 3, subtract 3. y2 is equal to negative 13. Okay? So endpoint 2 lies at negative 2, 13. Negative 2, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, which is approximately right there on my graph.